Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hi, friends. Wow. Welcome to Wednesday Night Math Night. Like Dr. A said, I'm Amy Sink, and I am one of the math specialists here at the Learning Liaisons. And it is just so good to see you guys. Hello, Hope. Hello, Trina. Hello, Natalie. Hello, all of you. It's so good to see you. Wow, I am struggling right now. Y'all, I cannot get rid of this cough or this like mucus in my throat. I don't know what is wrong with me. Y'all have been hearing it for like weeks, I feel like. We are here every Wednesday just building your competence and your confidence in math. Confidence is one of the main things. In fact, I was talking to a student today who literally told me today, like, I just can't do it. I'm done. I'm done with this class. I can't do it. I'm not going to pass the exam. Mind you, his exam is in 7 weeks. It's an AP exam, but his exam is in 7 weeks. So much time to build that competence and confidence. And I just spoke in him and I was like, if you go into that test with that mindset, you're right. You're not going to pass it. And so it's a lot of test taking strategies. It's believing in yourself. And then, yeah, you do have to know the content. But if you have a foundational understanding of that content, a lot of that other stuff comes into play into whether you pass or not. And so that's why we're here. I am happy to answer any questions that you have. As we are working through, please ask if you have any questions about specific things. So that shouldn't say notes. That should say next week. So right here, we're going to do a little next week section. So let me know in the comment box what you want to see me go over in the upcoming weeks. We had quite a few requests last week, and so we will be working through some of those today and next week. 2 weeks. Because y'all, guess what? Next week is spring break. I am traveling with my family. And so, we're not like going far, but next week is spring break. And so we are going to take a spring break. And so whatever that looks like for you, we will not be here next week. We are going to head out to see Disney for a couple of days with the little one. And so it's going to be so fun. I can't wait to see his little face when he sees Mickey and Goofy in person, because he loves to watch them on TV. And we've been, but I mean, we live near there. And so I'm just excited to take him again. So we will not be here next Wednesday, but in 2 weeks, we'll continue to work through that next week section. We didn't even do an introduction. In the comment box, let me know where you're from, what test are you prepping for, and get to know you question. Have you ever been to Disney? And if so, what's your favorite park? I would say nostalgia says my favorite park is Magic Kingdom, but I am a sucker for Animal Kingdom. I love Animal Kingdom. I love the safari. I love the Lion King show. I had a dream of being the flying bird in the Lion King show for so long. Yes, that is my favorite park. So have you ever been to, I've never been to Disneyland though. And so I would love to go to Disneyland one day, but I've heard that Disney World is better. I mean, I might be biased because I'm from Orlando, but so let me know in the comment box where you're from, what test are you prepping for, and have you ever been to Disney World or Disneyland or anything like that? All right, now that we've done introductions, let's go ahead and get started with our first problem. A rectangular garden is 12 feet long and 9 feet wide. A path of uniform width is built around the garden. If the area of the path is 164 square feet, what is the width of the path? If the area of the path is 164 square feet, what is the width of the path? All right, so this is an interesting problem because often we will see problems like this, but we're trying to find the area of the path. We're not trying to find the width or the length. So this is a fun one. So a rectangular garden, I'm going to draw my rectangular garden here. And then I'm going to create my path of uniform width. So that means that it's the same width all the way around. And they told us that the area of this path, so all of this section, equals 164 square feet. And they want to know the width. And we know that this is a 12 by 9. We know this is a 12 by 9. So I can easily figure out the area of my 12 by 9, right? Because area of a rectangle equals length times width. So I'm going to use my handy dandy calculator to do 12 times 9 is 108. So this equals 108 feet. And I want to figure out the width of my garden. Well, how would I go about figuring out the area of that? Well, I could do one of two things. I could cut this into rectangles, right? So I have this rectangle, this rectangle, this rectangle, and this rectangle. And I could find the area of each of those, right? So these two rectangles would be 12 times W, right? 12 times W. And there's two of them. And these two rectangles would be 9 plus 2W times W times 2. And you're like, whoa, Amy, what did you just do? Let me explain. This entire distance is 9 because this area, that section is 9. But then if it's a uniform width, then this is W and this is W, right? So that would be 9 plus 2 W's for that whole length. And to find area, I have to do length times width, correct? Which is also W. So I would do this times this to get the area of one rectangle times 2 to get 2 rectangles. But I am quickly realizing that this is a lot more variables and a lot more steps than I want. So you know what I'm going to do? I'm going to play with my answer choices. So I'm going to use 2 feet and I'm going to find the area of this rectangle. And I'm actually going to use the subtraction method because as I did all of this, I realized this is a little bit more than I want to bargain for. So I'm going to redraw this 12 by 9. And then I'm going to create my path. And this side we already did was 9 plus 2W. And this side is 12 plus 2W. But if I said that the width was 2, so let's pretend like the width is 2. This is 2, this is 2, this is 2, and this is 2. Then this whole length would be 9, 10, 11, 12, 13, right? And this whole length would be 12, 13, 14, 15, 16. Now watch what I'm going to do. I'm going to find the area of this whole green rectangle, which would be 13 times 16. 13 times 16 is 208. And then 12 times 9 is 108, right? We already did that. And 208 minus this 108 is 100. Does that equal an area of 164? No, it does not. So you know what I'm going to do? I'm going to skip over the 2.5 and I'm going to jump right to 3 because I feel like I'm missing quite a bit here. And so I'm going to jump to see if that works. So now I'm going to redraw. I'm going to erase this one because we didn't really use this picture. I'm going to do it again. This is still 12 and this is still 9. But now this is 3, 3, 3, and 3. 9 plus 6, 9, 10, 11, 12, 13, 14, 15. 12, 13, 14, 15, 16, 17, 18. Find the area of the whole thing. 15 times 18. And we already know 12 times 9 is 108. 15 times 18 is 270 minus 108 is 162. So now I have to do 3.5. I have a feeling I don't have the correct answer here. I have a feeling that this should have said 162. If I'm being 100% transparent, I found like an AI system that helps you write test questions, and I shouldn't have trusted it is what I should have done. So if I do 3.5, so 9, 9 plus 7 is 16, 12 plus 7 is 19, 16 times 19 is 304, minus 108 is too much. So we're going to say that this should have said 162, and then our answer would have been 3. But that process is really what we're looking for, right? That process is really what we're looking for. Hello, Leanne. It is good to see you. All right, Trina, Amy, any tips on how to best prepare for the teaching scenario parts for teaching math on the Praxis? That is an interesting question. There is not like a curriculum per se. I would say that there is parts of that in our boot camps. So you can definitely check into our boot camps. And I would say that just by listening to me go through tons of content, you're kind of like, even if I don't go over specific teaching scenarios, you're kind of like absorbing it through osmosis, just listening to me talk about all of the like different math content and stuff. I would say you're trying to look at it through the lens of the state or the test taker and test makers, not necessarily like practicality in the classroom, because what is best practice is not always what's practical, if that makes sense. What is best practice all the time, what you should be doing 24 hours a day, 7 days a week in your classroom is not always what's practical, but they're looking for best practices. And so if you can kind of keep that in the back of your mind, that will help. When I was taking the Feely, which has a huge component of how do you handle scenarios in leadership situations, that was probably one of the best pieces of advice someone gave me, because you just can't study all of the scenarios that they're going to give you. Another thing that I would say is manipulatives. If you know what manipulatives can go with what concepts, a lot of times they're asking you what's the best way to teach a concept, and that is going to be through hands-on experiences. And so if you're really not sure of the answer and you see something about manipulatives and it goes with a problem, I would say, like, if you have no idea, that's always a good guess. You always want to look for concrete teaching to pictorial or numerical representation to abstract. And outside of that, I will try to do at least one like practical like scenario question each week. So practical scenario questions. All right, let's go ahead and move into problem number 2. A bag contains 5 red marbles, 3 blue marbles, and 2 green marbles. If one marble is randomly selected from the bag, what is the probability that the marble is either blue or green? What is the probability that the marble is blue or green? All right. So a bag contains 5 red, 3 blue, 3 green. Someone specifically requested probability, and someone specifically requested measurement on the GK. This would absolutely be measurement and geometry on the GK, and this would absolutely be probability. So here we go. So a bag contains 5 red. I'm going to draw my bag. 5 red, 1, 2, 3, 4, 5, 3 blue, and 2 green. If one marble is randomly selected from the bag, what is the probability that the marble is either blue or green? So, little mini probability lesson. Probability equals desire over total possible. Desire out of total possible. That kind of looks like a fraction, doesn't it? A fraction, when we look at a fraction, it's a part of a whole. This is my whole in my probability world, right? All of this kind of stuff is interrelated. Fractions, decimals, ratios, percents, probability, it's all kind of interrelated. So a bag contains 5 red, 3 blue, 2 green. My total number of marbles in my bag. What is my total number of marbles in my bag? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 marbles, right? And my desire is to pull either a blue or a green. A blue or a green. So how many blue or green marbles are there? 5. Well, you'll notice that 5 out of 10 is not there. That's because I can simplify this. 5 divided by 5 and 10 divided by 5. I'm not changing the value of my fraction if I divide the top and the bottom by the same thing. Equals 1/2, which is B. Questions about this probability problem. Probability in statistics always stumps people up. Probability in statistics always trips people up. All right, let's go ahead and move into the next problem. Which of the following graphs correctly represents a line with a slope of -2/3? Which of the following graphs correctly represents a line with a slope of -2/3? All right, this is another problem that was directly requested, so we're going to go through this. All right, so when we're thinking about slope, we're thinking about, and especially if they've graphed it for us, we're thinking about rise over run. We're thinking about rise over run, which is the change in y over the change in x. So if I am rising and running, I'm looking for, this is my rise and this is my run. Now, here's a little tidbit. Which direction do we read words in? Which direction do we read words in? From left to right. Exactly. We read words from left to right. We read graphs from left to right as well. We read graphs from left to right as well. So if I look at each of these graphs and I go from the left to the right, 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 which direction is this going in? A positive direction. Which direction is this one going in if I'm going left to right? A negative direction or down. Which direction is this one going in? Negative or down. And which direction is this one going in? Positive or up. So that means that this cannot be my answer and this cannot be my answer, because my slope is -2/3. My slope is -2/3, which means I need one of the negative slopes. Now I can, it's a 50-50 shot. I can zoom in, find 2 points, and count my slope. So I have a point right here, right here, right here, right here. So to get from this point to this point, there's my triangle. There's my triangle. There's my triangle. So I'm rising -3 and I'm running +2. So this one has a slope of -3/2. Let's look at this one. Rising 2, -2, running 3, -2, running 3. There is our winner. There is our winner. All right, we have time for one more problem, and I have to cut out early tonight due to a childcare situation. So we're just going to cut out a little early tonight. We're going to do one more, though. All right, let me see. Oh, this is another good one because a couple of people asked about slope, and so I wanted to make sure we talked about slope tonight. So let's read this one, and then we'll be done. What information can you deduce from the following equations? What information can you deduce from the following equations? The lines are parallel and have different y-intercepts. The lines are perpendicular with an intersection point at 2, -3. The lines are non-perpendicular intersecting lines with an intersection point at 2, -3. Or the lines are perpendicular lines with different y-intercepts. So what do we know about parallel and perpendicular lines? Parallel lines have the same slope. Perpendicular lines have negative reciprocal slopes, which means if the slope of one line is a over b, the slope of the perpendicular line would be negative b over a. The only problem is these are not in slope-intercept form. They're in standard form, which in my opinion is useless form. And so we can't figure out what the slope is unless we put them in slope-intercept form, which is y equals mx plus b. So I just need to get these to equal y. So I'm going to subtract 2x from both sides. And divide by 4. And I'm going to do the same thing for this. I'm going to subtract 6y from both sides and divide by -3. So what I see is that these lines are most definitely not parallel because they do not have the same slope. Are they perpendicular or not? Are they perpendicular or not? They are perpendicular because one is -1/2, the other one is positive, and literally the flipped version of that, which is 2 over 1. So they are perpendicular and they have different y-intercepts. So I don't even need to test if they have an intersection point at 2, -3. Either they have different y-intercepts or they have the same y-intercept, which means that they would have to have an intersection point at 2, -3. So I don't even have to test that piece. All right, Trina, if I shaded the graph, how would that look in problem number 3? So I can't shade these graphs because they are not inequalities, they are equations. I will absolutely include an inequality graphed problem in 2 weeks, maybe next week. I started thinking about it and maybe I can do it from the hotel room and we can all just look at fireworks together. So we'll see. But I can absolutely include that in the upcoming weeks. I can do a graph, an inequality, a linear inequality, and I can do a choose the correct graphed linear inequality. So I can absolutely do that. Graphed linear inequality. All right. I am going to turn it back over to Dr. A, and I will maybe see you all next week. I have to figure out what the whole situation is, and I will maybe see you next week. Check out our Facebook and we will keep you updated there. Bye, guys.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions that I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35. That will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.